We are going to talk about factoring, and in this case I'm going to be discussing type 3 factoring. Now what I mean by type 3 factoring is I've categorized polynomials into different types. Type 3 follow the form x squared plus bx plus c, and that means my first term is always x squared, my coefficient is always a 1. If I don't see a coefficient, it's as if there is a 1 there. So my bx term means any real number b with an x plus c, another real number constant. So an example of a type 3 polynomial, x squared plus 7x plus 10. And I want to factor it, and we have to remember what factoring means. I want to reduce this to a product of prime numbers. That's what factoring does. If I have the number 6 and I want it as factors, I would say 2 times 3. So 2 prime numbers are multiplying out in that case. So I'm going to get 2 binomials, and they are going to multiply out to x squared plus 7x plus 10. You can think of this as reverse FOIL in a way. When I use repeated distribution on 2 binomials, I can use that FOIL method, and I do get a product of this form. So now I want to work backwards. What 2 binomials are going to give me this trinomial? So let's start this way. I draw my 2 parentheses. I'm going to be putting 2 binomials here, and I know I want to multiply them. Now I know I multiply these first terms. Well, if this is x squared, the only way that I can get an x squared is if I have an x and an x. So I automatically, whenever I see a type 3 factoring, I start this way. I kind of build my binomial parentheses, placeholders there, and I begin with xx. Now what I need to do is I have to figure out, well, obviously what goes here. So I ask myself a question. The question I ask is, what 2 factors of 10 add up to 7? And where did I get that question from? I look at this term, what 2 factors of 10, and remember factors are multiplying, add up to that 7. And why am I doing that? Again, I'm kind of deconstructing the multiply that I used to get here. Well, how did I get a 10? Well, I had to multiply the 2 terms that are going to go here. So 2 things have to multiply to 10. So that's why I need factors of 10. And where is the adding up coming from? Well, to get that middle term, that's the outsides and the insides, if I'm using FOIL. So I'm going to multiply here and then add that to this. So something times something has to add up to that 7. And the way I figure this out is, well, what are the factors of 10? And I'm just going to list them. I've got a 1 and a 10. Well, let me see. Do they add up to 7? Well, no. 1 and 10 is 11, not 7. But 2 and 5 are also factors. 2 plus 5 do add up to 7. So those are the factors I'm interested in. So I can start filling this in a little bit more. I know that the 2 outside terms here are going to be 5 and 2, because 5 times 2 is 10. And I know when I add these numbers, I'm going to get 7. Now, again, just to be sure, how do you know that this should be an add? The way you know that is, again, you look at this last term here. I add 10. I'm multiplying a 5 times a 2. How do I get a positive number when I multiply 2 other numbers? Well, it must be the case that both numbers are positive or both numbers are negative. Well, what's true in this case? I know that it has to be positive because of the outsides and the insides. I want to get a positive number when I add them together. So it must be that I'm adding 5 and I'm adding 2. If I had made these both minuses, I would get x squared minus 7x plus 10. So those would be the factor of x squared minus 7x plus 10. So the signs here give us clues about what's going to happen here. There's a lot to think about, a lot to do, so you always, always, always want to verify. You can verify these factors very easily. You just multiply back and see if you get that original polynomial. I'm kind of talk through the FOIL method here. My first terms are x times x, gives me x squared. Then I do my outsides, 2 times x, plus my insides, 5 times x, 2x plus 5x, gives me the 7x. And then my last terms, 5 times 2 gives me 10. So I know I've got the correct factoring. Do not skip this step. It takes a second. You will be surprised how very good you get at using that FOIL method. You'll almost do it in your head instantly. But take that time and do it. You don't want to factor these incorrectly, because they can get more confusing than this. And speaking of that, I would like to look at another example because this one, a little bit more confusing, not difficult, but just not quite as straightforward. If I want to do x squared minus x minus 20, I want to factor this. So let's see. I always start the same way. I start with my two parentheses there. They're going to hold my binomials that I'm going to be multiplying. And I know that first term has to be x and x. When I have something of this form, a type 3 polynomial here, it must be this was x and that was x. It's the only way I can get x squared. Okay, now I have to ask that question. What question should I ask here? Oh, let's see. Well, this is a 20. What two factors of 20 subtract to 1, because there's a 1 in front of here, or I can think of it as what two factors of 20 add to negative 1, because there is that negative sign here. And again, the easiest way, let's just list the factors of 20. I've got 1 and 20. Did they subtract to 1? No, 20 minus 1 is 19. How about 10 and 2? Well, 10 and 2 subtract to 8. Well, 5 and 4, they subtract to 1. So this is what I'm interested in. Or I can think about how do they add up to negative 1. Well, other factors of, say, negative 20 would be negative 5 and 4, and that's going to give me the negative 1. But for now, let's just put in our 5 and our 4. We know that has to be the second number for these binomials. Now 5 times 4, in order to get a negative 20, because there's a negative sign here, it must be that the signs are different. One of these is a plus, and one of these is a minus. Now how do I know which one? Well, if we think about how do we add these up to negative 1, well, it must be that this is negative 5, and that's a positive 4, because negative 5 plus 4 is negative 1. If I do it the other way around, I would get 5 minus 4, which would give me a positive 1. But it's clearly negative. So I want to put my negative sign in front of the 5 and my positive sign in front of the 4. So this can be a little confusing at first. So again, always, 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 multiply back. Do I get my original polynomial? Well, x times x, x squared. Do my outside terms, 4x. Inside terms, minus 5x. What's 4x minus 5x? Negative x. And then I do my last. Negative 5 times a positive 4 is a negative 20. Now if you had flipped these by accident, you got a little confused. When you do the verify step, you would have a plus over here. You'd have plus x. So you know, whoops, I switched them around. So please do not skip this step. Again, they get very, very fast. You get really good at it. You will also get really good at doing this method. This is also called the mental math method. There are other methods for factoring polynomials, and we'll talk about them more in type 5 factoring. Type 5 factoring is where this is no longer a 1. You've got something else here, 5, a 10, whatever. So they're a little bit more complicated to do with mental math. So we have these other methods, and they work for this. But I think it's much simpler to kind of master this for simple polynomials where you've got a coefficient of 1. So keep practicing, and good luck.